So recently I came across this post where this person describes how they cut GTA Online loading times by 70%. Now the issue might not seem something special, I mean games are notorious for being slow to load, but the point is that the bug that causes this problem is actually quite widespread, or maybe I should say it's something that if you do not know your way around your compiler source code, you will never be able to understand why it happens. So just for the introduction, so this guy says that they discovered that GTA Online's loading time is very slow, and as you can see here, story mode's load time is 1 minute 10 seconds, whereas the online mode's load time is around 6 minutes. Now they did a poll where you can see that around quite a lot, over 80% of people have experienced the same issue. So they did quite a bit of digging, and the bug that they found is actually in the implementation of C libraries. So this bug is not a result of a mistake that the programmer of GTA Online did, but instead it's something that happened in the implementation of the C library. So what is that? So the answer lies in the scanf function of the C library. So let me explain it. Now here's a quick reminder on how C works and the functions of C. So you probably know, if you have done C, you probably know the function scanf. So what it does, it reads input of the user with a specified format and then puts the values or extracts the values from the input and then puts them in the variables. So for example here, the format tells scanf what data or what type of data the user should enter. So %d stands for a decimal number and %c stands for a character. So this format tells that the user will first enter an integer and then enter a character. And as you can see, I have a variable x and I have a variable y, and so I tell scanf you put the values in this order. So the user will first enter, let me zoom it in. So the user will first enter an integer which scanf will put in x variable. The user will then enter a character which scanf will put in y. And if I run it, the result, as you can see, so if I enter an integer and then I enter a character, and as you can see, scanf has put them in their actual places. Now scanf reads from the standard input, which is basically the keyboard, and there are variations of this function which read from different places. So for example, there is a function called fscanf which reads the input from a file. There is a function called scanf which reads the input from a string. So instead of reading from the keyboard, it reads the input from a string. Now this is our culprit here. So let me explain how this works. So scanf is almost similar to scanf, except it takes one more input, which is the string from where to read the input. So if I write the string, for example, like this, so the rest of the part is similar to scanf. So it tells that the same thing, the first input will be an integer, the next input will be a character, put the integer in x, put the character in y, except read from this string. So this string should follow this format. Now if the string does not follow the format, there is an undefined behavior, but for now let's assume that string follows that format. So I have an integer first followed by a character. Now if I run this program, this should give me the same output, as you can see. So 2 and a, I wrote a here. Now here's a quick primer on how strings work in C. Now as you might know, that C does not actually have a string. So in order to use strings, quote unquote strings in C, they are actually array of characters. So when I write this is actually an array of character. So I can store it in an array of character. Like this. In C, as there is no notation of an object, there is no way you can store the length of an array. So you have to supply the length of an array whenever you want to deal with an array, because when you pass an array to a function, it actually decays to a pointer to the first element. So in this case also, this array is basically the same as writing the pointer. So this is basically the pointer to the first character a, and when I increment the pointer, I will print everything what is after that. So let me show you how. So I will remove this for now. So if I print a character pointed by the pointer string, you will see I will print the first character of the string a. And now if I keep incrementing the pointer, I will actually start printing the next elements. So when I increment it by 1, I print b. Now it's alright if you do not know pointers in C. I have a blog post that goes into way too many details about pointers. I will put the link in the description, which you can check it out. But here's the problem. So when I am dealing with strings, it's very much inconvenient to pass the length of the string, because I mean, it's a string, right? It should not be that difficult to get the length of the string. But how will the compiler know when the string ends? So for that, they have a trick. The trick is that when you write a string, it actually inserts a special character at the end of the string, which is the null character. So you do not have to insert this, the null character will automatically be inserted. So when I write ABCD, it means that it is ABCD followed by one null character. And as you can see, my VS Code is giving me a hint that this is a 5-element array, but there is only 4 characters, which means it actually has an invisible character at the end. So this null character tells when the string ends, and all the algorithms or all the functions that work with strings actually will check for the end of the string using this null character. And one of the most important functions is the strlen function. So let me show how that works. So for that, I have to include stdlib, and I can print the length of the string by calling the function strlen. And passing the string. My bad, it sure is not strlib.h, it's actually string.h. Anyway, so now when I run it, you will see it prints 4, which is the length of the string. Now of course it did not print 5 because it does not include the null character, but how does it calculate the length of the string is just, as you might guess, it goes over the string one by one, and when it encounters a null character, it takes the count. So we can actually write one of our strlens very easily. So let's do that. So I will have unsigned long, let's say my strlen, and it will take a pointer to a character. Now I will create a counter, and I will loop over the pointer. So the way it works, it checks if the character pointed to by the string is null character or not. So as long as it is not null character, we increment the count, and we also increment the pointer so that it points to the next character. So once I encounter the null character, I stop the loop and return. So now let us change this call to my strlen and run it. As you can see, it gives the same output. So the thing to remember is that the strlen function loops over the entire string, which means it is actually a linear function, or O of n if you use the big O notation. So what does this have to do with scanf? So let us see the source code of scanf. So this is the source code of scanf in glibc, which is the GNU's implementation of C library. Now most of this bug actually occurs in most of the C implementations, so not only GCC, but let me show it. So this is the scanf function. As you can see, it takes a string, which is my input. It takes a format, which is basically tells what kind of data to expect, and then 3 dots or the ellipsis. So the ellipsis stands for variadic arguments. which means that this function can take more than one arguments, or not more than one, it can take any number of arguments. Now if you do not know about variadic arguments in C, it's very easy. So basically you just declare your function with 3 ellipses, but there are a few restrictions. For first of all is that your function must take at least one fixed argument, and then the ellipses must occur between or occur after all the fixed arguments are there. And finally you need to know what type of data each argument is. So here the function knows what kind of data to expect by using the format argument. So when I write, I have deleted that. So when I write %d%c, it knows that the first variadic argument will be an integer, the next variadic argument will be a character. So basically you convert this to a VA list, which is a list of arguments. So you first call a VA start function, and using this VA start function they generate the list of the argument. Now I do not want to go into too much detail about the variadic arguments because that will be distracting. So the point is that it calls another function which is sscanf. So sscanf is the same thing as this, except that instead of taking any number of arguments, it actually takes a VA list, and when it calls the function and when the vscanf function returns, it just returns the value. So let us see what the vscanf function does. So here is the vscanf function. So as you can see here, it calls a vfscanf. Now f, the second f here stands for file, which means that it is reading from file. Now here's the cause of the problem. So they have the vfscanf function which reads from a file, and they wanted to reuse that function in this vscanf also, but vfscanf reads from a file, so they need to supply some kind of file to this. So for that they create a fake file. So a file in C is basically a struct which holds some data. So as you can see here, it creates a file. This is a fake file, and they initialize this file using this function strlen static internal. So they pass the structure that they just started, then it passes the actual string which it got as input from the scanf function. Then they need to pass the size of the file, which they pass as 0, and finally a null pointer, which now the file needs to hold some kind of pointers for the write head and other things. So this null pointers, it means that this is actually a fake file. So the only thing is that they just convert the string into a file, so as if the file holds this text or this string. So when the function vfscanf reads from the file, it will actually read this string, which is pretty ingenious, but the problem lies in the size. So they pass a size of the file as 0. Now let's take a look at what this does. So this is the strlen static internal function, pretty demonic name if you ask me. And here is the thing, they, as you remember, they pass the size as 0, and if you see, if the size is 0, they call a raw memchr function on the pointer with the null character. So what this does, this size is used to calculate the end of the file, and the end of the file, when the size is 0, in order to calculate the end of the file, they pass the string that they just got from the vscanf function into raw memchr and as null character. Now what does the raw memchr does? Let's see. So here is raw memchr, and as you can see, its description says find the first occurrence of C in S. So find the first occurrence of C in S. So S is a string and C is a character. So this is basically finding a character inside a string. Now if you remember, we passed null character, which means it actually is finding a null character when the null character occurs in the string. So as you can see, if C is not 0, it calls a memchr function. Let's not worry about it, because in our case C is actually null character. So what does this do? As you can see here, it calls strlen on the string, and as you might remember, the strlen loops over the entire string in order to find the null character. So just to clarify, or just to remind ourselves of what happened. So in short, I am not writing the entire names, I am just writing it in short. So we have the scanf function which calls the scanf function, which calls raw memchr function, which again calls strlen, and strlen loops over the entire string. So if you have a loop where you loop over your string and call scanf for every time in the loop, so for example something like this, so you have for where you loop over the entire string and call scanf on the string. So each time you call scanf also calls strlen, and strlen also loops over the entire loop. So as you can see, this is actually a quadratic for loop, which means it's O of n square. This takes quadratic time, which means this is the reason where your program will slow down. So how does this affect GTL? Let's see. So if you go to the blog, you will see that it is actually trying to parse a JSON file, and as you can see, so it has some 63,000 item entries. So this is a huge string, so around 10 or 12 megabytes, and they are using scanf to parse the string. So in order to take, say for example, these numbers out or these strings out, they are using scanf. So this is generally what is happening. So they are looping over the string and calling scanf. So for example, to extract this digit, they are calling scanf with a %d, which means we are expecting an integer, and this scanf calls strlen. So it counts every single character. So from the start of the pointer p, it counts every single character and then returns the result. So then it moves the pointer next to a few more characters and then calls it again. So this goes on and on and on, and as you can see, this turns quadratic. And as is said in the blog, that to be fair, I had no idea most scanf implementations called strlen. So basically you should not know that scanf implementation would actually call strlen. This is something that unless you go into the source code of your C compiler, you will never know. But it is something to keep in mind now that you know. So when you want to use scanf, do not loop over the string and call scanf. It is a bad idea. So there are other ways to read data from strings, but using scanf over a loop is not the greatest idea. So that was all about this video. Thank you for watching, guys, and if you like this video, hit that like button and don't forget to subscribe and stay tuned for more videos.